Hello and welcome. Today we're going to be starting a totally new series in Python, and we're going to be concentrating on data structures and algorithms. If you're going to want to work in a very big firm like Facebook, Google, Amazon, all the leading tech companies, when you go for an interview, you're going to be tested on data structures and algorithms, most likely. And that is why we are making out this time to study data structures and algorithms using Python programming language. And to do this, I'm going to quickly share my screen so that we can join up immediately and start. Okay, good. Please, can you see my screen now? It's showing okay. So like we always do, get to our website, tclassified.com, click on blog. Then once you're on blog, you can see data structures and algorithm. That's what we are looking at today, data structures and algorithm. So quickly click on data structures and algorithm. Okay, so once you click there, you're going to be led into what we have today. So what are data structures and what are algorithms? In Python, your data will be organized in data structures, and you're going to use algorithm to manipulate those data and make them perform the function that you want. We've already looked at the built-in data structures. When we were introducing our Python, we looked at list, we looked at dictionary, we looked at tuple, and we looked at set. So those are built-in data structures in the Python. Python comes with them. But we also have the user-defined structures that you can define by yourself. Examples are the stack, the queue, the tree, the linked list, the graph, and the hash maps. So we're going to be looking at examples of all these data structures. We're going to experiment with them. We're going to know what they do. So your data in Python, you can arrange them using data structures. An example of those data structures are lists, dictionaries, tuples, sets. We already know what these are, but we're still going to look at them. So other examples of data structures include stack, queue, tree, linked list, graph, and hash maps. So what do you use algorithm to do? You're going to use algorithm to solve problems. Algorithms are simply step-by-step way of solving a problem. And in solving this problem, you're going to be using data structures. You're going to learn how to use algorithm, manipulate your data structures, or even without data structures, how to solve problems using algorithms. And those are what we're going to be looking at today. So the built-in data structures, we have the list, which can have heterogeneous data types in them. And lists are mutable. When we say mutable, it means that it can change. You understand? That's the meaning of mutable. Examples of lists are when you say A is equal to, you can see that it's having 12, it's also having XYZ, and it's having 34. That means it can contain heterogeneous data type. It's not containing only integers. You can see it has integer, it has string, it has another integer. So you can print it out to see how it looks. So we're going to test this out in our VS Code. So open up your VS Code. So you can see my VS Code. I've opened it up. And I created a new folder on my desktop. I call that folder AgDS, meaning algorithm and data structure. That is the folder that we're going to be using to work today. So open up your VS Code, AgDS. That's algorithm data structure. That's the name. So I'm going to open up my terminal so that we can start writing out these data structures and coding them out. But before we continue coding, please quickly create a new folder on your desktop, call it AgDS, then open it up on your VS Code so that we can start writing code. But before we start writing code, I'm going to still run this through. So because we say that lists are mutable, that means after creating your list, you can go further to append something to your list. You can see we appended 3. If you had a tuple and you try to do b.append or a.append as we created here, you will not be able to append because lists are immutable. I mean, lists are mutable, but tuples are immutable. If you try to perform this append function on a tuple, it's not going to work. So what are tuples? You can see tuples are not mutable. They are not mutable. You cannot change them once you create them. So if you're looking for a data structure where the values cannot be changed, you use tuple. But if you're looking for the one where the values can change, you use what? List. So what are dictionaries? Dictionaries are what we call key value pairs. So in dictionary, you have a key, then you have the value. Just like this dictionary, D equal to 1, Python. So the key is 1, the value is Python. The number 2 key is 2, and the value is what? Java. So once you're having a key value pair, we call it dictionary. Okay, then we have sets. Sets are another collection of unique elements, and they are mutable as well. So these are sets. Now, what are algorithms? Algorithms are rules or instructions that are formulated in a finite sequential order to solve problems. They provide the pseudo code for the problems. So we're going to be using algorithms to solve problems. Algorithms are what? Instructions. They are sets of instructions organized in order from the starting to the ending on how you can use it to solve problems. If you want to work on a string, let's say you want to convert a string to a list, you have steps that you're supposed to take. Those steps organized in order in which you're supposed to take them is what we call algorithms. And in writing algorithms, you need to figure out what the problem is that you want to solve, need to determine where you need to start from, need to determine where you need to stop, and you need to formulate the intermediate steps. So when you're writing your algorithm, you know where you want to start, where you want to stop, and the steps that are in between. Then you review these steps, make sure that they are very effective. Then what are the elements of good algorithm? The steps should be finite, clear, and understandable. All your steps has to be finite, clear, and understandable. Should have clear description of the input and output. You should be very clear with your what are you taking in and what are you giving out. Each step must have a defined output that depends only on inputs in that step or the preceding step, and the algorithm should be flexible. When you create an algorithm that solves a problem, it should be flexible so that when there are changes, that algorithm can still solve such problem. The steps should make use of general programming fundamentals. If you create your algorithm, it should be used for both Python, JavaScript, and any other language. There are different classes of algorithm, 3 classes of them. We have what we call the divide and conquer algorithm. We have the dynamic programming algorithm, and we have the greedy algorithm. Those are the 3 classes of algorithm that we have, and we're going to be explaining them in due course. The divide and conquer divides the problem into subparts and solves each one separately. The dynamic algorithm divides the problem into subparts, remembers the result of the subparts, and applies it to similar ones. Whereas the greedy algorithm involves taking the easiest step while solving a problem without worrying about the complexity of the feature step. So these are basic definitions of these various classes: divide and conquer, dynamic programming, and greedy programming classes of algorithms. Okay, so we're going to be stopping here. We're going to be moving into our VS Code to type out these algorithms and check them out. So number one thing we did was that we said that there are 2 types of data structures, isn't it? The built-in data structures and the user-defined. So the built-in data structures are the ones we've looked at already, which are the list, dictionary, tuples, and set. The user-defined structures are stack, queue, tree, linked list, graph, and hash map. So let's start from the beginning. So we are going to start with the user built-in data structures, the lists. Okay, so let's get back to these are VS Code that we created. Then under it we have the what? argds. We created the argds. So let's create our first file. So what is the first data structure that we're looking at? Fortune. So let's look at lists. So we'll call it lists.py. That's the first data structure we're looking at, list.py. So from the text that we have here, you can clearly see what we are looking at under the built-in data structure. We say that lists have heterogeneous data types in them, and they are mutable. So let's create a list. So the name of this list, we are giving it variable name A, and we are creating it to 12, XYZ, and 34. So let's create this list. A equal to, whenever you want to create a list, it must have a block bracket. Block bracket. Very, very important. The square bracket, that's what you are using. The square bracket. If you use any other bracket, if you use the normal bracket, it becomes a tuple, isn't it? If you use the curly bracket, it becomes a what? Dictionary. So take note of that. So the type of bracket that you use, that's what determines the data structure. Very, very important. And whether it is mutable or immutable. So let's say A is equal to what? We put the square bracket. We say is equal to what? 12, comma, what? Again? XYZ. Sorry, I don't know why this is moving to the next. So we have 12, we have what? X. It has to be in quote if it's a string. I hope you know that. So we have X, Y, Z. Then we have the next one, which is what? 34. So why are we having, this is a string, this is an integer. Why are we having combination? Because we know that lists can contain what? Heterogeneous. All of them mustn't be the same. So that is our list. So we can print out this list by simply giving the word, saying what? Print, then in brackets we'll put what? The variable name of the list, which is what? A. So how do we run this code, class? So I'll do Control S to save once you do that. So how do we run? Who can tell me how we can run this code very fast? Good. Python, we've done this before. Python lists dot py. That's how you run this code. So you can see the list. Once you run it, you see we have 12, XYZ, and 34. So we can see we created our list here and we printed it out by using this command. It's as simple as that. So let's get back to the practice test. We can create another list. After creating the list, we can then start adding something to it. So let's try creating another list. And that list is going to be list of B. So we say B is equal to, once you put your square bracket, it has created this list. Even if you don't put anything inside it, this is an empty list. So let's try to print out this empty list by saying what? Print, then in brackets, we'll say what? B. So if I run this by saying Control S, then I come back here and say Python list.py to run it. If I save it by saying Control S and run, you can see now I'm having, this is the first list, which is the list of A, and the second list is an empty list. Now that I've created an empty list, we can append to it. If we had created a tuple, can we append to a tuple? No, we cannot, but we can do for a list. So how do we append for a list to a list? We simply say what? B, the name of that list dot append. Then you give the value you want to put. So I'm going to simply say what? B dot append. Once you're typing, your VS Code will even tell you the spelling. So what am I appending? I'm appending 8. So if I append 8 and I do Control S to save, then if I come back here now and run this code by saying Python list.py, you're going to see, oh, I did not print it. So I'm going to reprint B again after appending. So I'm simply going to pick this print from here and put it down here. Okay, then I'll save Control S. Then I can now run. You can see now that the second list B is containing 8 because I've appended this to it. And why are we able to append? Because we know that lists are mutable. Lists can be changed. So let's try out tuple now. So to do a tuple, I'm going to create another file, and I'm going to call it what? Tuples.py. So I'm going to create a tuple. So how can I create a tuple? All the instructions are on our website. Tuples are not mutable. And we're going to see why they are not mutable. So I'm going to create a tuple known as C, and I'm going to equate it to have different values of 3, 4, and 5. So let's create this tuple. We call it C, and C is equal to what? If you're creating a tuple, you use a normal bracket. If it was a list, you would have used the block bracket or the square bracket. So I'm going to be giving it the values 3, 4, and 6. So after creating this, I can print it out by saying what? Print. Using the print command, print what? C. So if I save by saying Ctrl S, if I want to run, what should I type now? Should I still say Python list.py? No, because I will now say Python what? Tuples dot what? Py. That's how you run. So you can see my tuples are printed out, 3, 4, and 6. Now let's try and do that same operation that we performed on list. Let's try to append. If you now say c.append, you can see I'm not even seeing append on it, just the way I saw the other one. So if I say c.append and I put maybe 9, if I try to append 9 and then try to print henceforth after I've appended, so I'm going to bring out down this print here. Take it out from here. You know that Python interprets line by line. So if I try to run this, you see that I'm going to get an error. C.append. I think I have an issue there. C.append print. Okay. I didn't save. Okay, so I'll go back, Ctrl S, please. Once you make any changes, make sure you save. So I did C.append. I hope my spellings are correct. So I tried to run this again. You can see it's telling me an error. Tuple object has no attribute append. You cannot append in tuple because tuples are what? Immutable. Once you create them, you cannot change them again. The way you've created them here, that's the way it's meant. Are we clear on that? So let's try the next data structure. What's the next data structure? What's the next data structure? Dictionaries. So let's look at dictionaries. So what are dictionaries? Dictionaries hold key value pairs. You understand? Unlike the other ones, they are holding their values, but you know they have their indexes of 0 to 0, 1, 2. You understand? You don't see them. But in dictionary, you show the keys. Let me tell you this again. Please, are you looking at this list? What is the index of 12? Who can tell me the index of 12? 0. What's the index of XYZ? 1. What's the index of 34? 2. Then when you get to the tuple, what's the index of 3? 0. What's the index of 4? 1. What's the index of 6? 2. All of them have indexes, but you cannot see them. But in dictionary, you have to indicate the key value pair. You understand? So the key you can equate or be likened to what the position of the value in the memory. Is that clear? And it has to be shown. So let's create this. So what should I call this? For the dictionary, I'm going to call it what? Dictionaries dot what? Py. Did I spell my dictionaries well? Dictionaries dot py. Okay. So I'm going to press the enter key. So I'm going to start to create my dictionary. So with what we have here, we'll have that dictionaries of key value pair. This is key value pair. Please, there is a mistake here. It's not just value pair. Key value pairs. Dictionaries are mutable. They can be changed just like the list. You understand? You can create your dictionary and add up some values later. But you cannot do that in tuple. I hope you are aware you cannot do that in tuple. You can only do it with dictionary and list because they are mutable. So let me create a dictionary and call it what? D. And assign in the values of, for number 1 key, value of Python, and for number 2 key, value of Java. Then we'll print it out. Okay. So let's say D is equal to, what kind of bracket do you use if you're creating a dictionary? Curly bracket. What? Curly bracket. So it has key value pair. Key value. There has to be a pair. If it has to be dictionary, pair, key and value. So what's the key? The key here is 1. What's the value? The value is what? Python. The value is what? Python. Then you go over, put comma, create the second key. What's the second key? 2. What's the value of the second one? Java. Okay, so that's how you create a dictionary. So I can simply print it out so that we can see it on my console. So if I say print, and in bracket, I put the variable name, which is D, and I do Control S to save. If I want to run, what should I run with? Python what? Dictionaries dot py. That's how you save. Okay, so you can see my dictionary here. Number 1 is Python and 2 is what? Java. So if I want to add up more value, I can do that. I can append more values because it is what? Mutable. Because it is what? Mutable. Okay. So let me quickly get to sets so that we'll stop at sets now. So that in subsequent classes, we'll look at other data structures and we'll enter algorithm. So what I said, sets are unordered collection of unique elements. Sets are also mutable. They are unordered. Unlike the other one that you have to order them. In sets, you don't order. And they are also mutable. That means you can change them. So I'm going to create a set E and assign it values and print the set. Okay. So I'm going to create a new file. So what should I call this file? Sets dot py. Sets dot py. Okay. So let's create this set. From the text we have here, I have that the set is equal to what? 2, 3, 4, and 2. 2, 3, 4, and 2. So we have E. We are assigning it the variable name as E. Making it equal to what? 2 what? 3, 4, and 2. Okay, so we'll try to do what? Print it out by saying print what? E. Then we'll do Control S to save. Then we'll come down here. If you want to run, what are we going to say? Python what? Sets dot py. Okay, so you can see the sets 2, 3, and what? 4. So with that, we'll come to the end of the basic built-in data set. We've already checked out these data sets in our basic Python, isn't it? You know that there are other functions that we can manipulate with this. Are you aware? It's not only append. There are plenty other functions. So check out our lectures on basic Python so that you check out these data structures and see other functions and methods that you can perform with these various inbuilt data structures. So in the next class, we're going to be looking at user-defined data structures like the queue, stack, hash maps, and the rest of them. Yeah, so please remember, anything you want is in Christ Jesus. The easiest way to get into success is by being a born again. See you when I see you again. Thank you.
Hello.